Welcome! Let us start our sixth lesson of statistics. Today, we are going to talk about the topic how to visualize numerical data. Once again, at the end of the class, we will have fun practical examples provided in Excel and in Python. In previous lectures, we have learned the difference between categorical and numerical data. Remember, numerical data always involves some kind of measurement, or it is a quantity that can be counted. For example, the weight of cats that have visited a pet store in one day. To obtain this data, you need to weight the cats on a scale. You need to measure them. In turn, to quantify the number of romance books in each apartment of a given flat, you need to count the number of such books for each apartment. In contrast to numerical data, categorical data is non-numeric information that can be expressed as a list of words. We have seen this already. Today we are going to talk about numerical data visualization. Numerical data visualization presents numerical data in the form of charts, graphs, and other visual aids. These are a useful way of better exploring, understanding, and communicating data. So 3 objectives: explore, understand, and communicate. The goal here is to summarize and aggregate information to better show the relationships and patterns found in the data. A good definition of numerical data visualization is that it involves the use of visual representations to explore, make sense of, and communicate data. We need to explore the data in our search for significant facts. Visual aids are important here. For example, sometimes in a pie chart we can immediately spot that one class of data that is more frequent than the others. We also need to make sense of the data to gain deeper and holistic understanding of it. Visualization reveals the big picture, gives an overview of the dataset. For example, in a bar chart about beer consumption, we can notice that, on average, people drink quite extensively in Germany. Finally, if we can better understand data in a visual form, so can others. It is then useful to use visual aids to convey information to others. The first thing we can do, especially for numerical data, is to examine the data in a frequency table. After that, we can apply a visual tool to the data. We have many graphical options for numerical data. Some of them we will discuss here, such as stem and leaf plots, dot plots, line graphs, histograms, frequency polygons, and time series plots. Each of these methods comes with its own advantages and limitations. Let us examine a type of graph called the stem and leaf graph or stem plot. This graph is a suitable option for small datasets. It is represented as a special table where each data observation or value is split into a stem, that is the first digit or digits, it depends on what you want, and a leaf, which is usually the last digit. For example, you could divide the number 54 into a stem of 5 and a leaf of 4. The number 81 could have a stem of 8 and a leaf of 1. In another dataset with decimals, the number 9.2 could have a stem of 9 and a leaf of 2. Let us see how to create a leaf plot using an example from a philosophy class. In this philosophy class, there was a first exam, where the students scored these marks that are shown here in increasing order. We can create a stem plot from this data. Let us create a table with 8 entries. First, we write the stems in the first column, from smallest to largest. The stem will be a list of the first digits in the data. In the second column, write the leaves in increasing order next to their corresponding stem. For value 33, write 3 next to the row with stem 3. For value 42, write 2 next to the row with stem 4. Continue this reasoning until all observations are represented in the second column of the data. Looking at the STEM plot, we can see that most scores fell in the 60s, 70s, 80s, and 90s. We can see that only one student had a score in the 30s, which is good. And we can also see that 4 studies scored below the score of 5. One student at the 30s and 3 students at the 40s. STEM plots help to organize things and give a nice overview of the data. They can be good for exploring individual observations. They can be used for discrete data or ungrouped continuous data if the dataset is small. It isn't feasible to make these types of tables for large collections of data, but we will see other charts that can be used for that. Another type of graph is the line graph. This graph is useful for showing trends in discrete and grouped data from small datasets. Please note that line graphs can also be used with ordinal categorical data. Okay, let's see this chart in an example. In a survey, 40 children were asked how many times in a school week they skipped their homework. We show the results in a frequency table. In a line chart, the horizontal axis, what we call the x-axis, consists of data class values, and the y-axis, the vertical axis, consists of frequency points. We can see that the first point has the coordinates 0 and 2, corresponding to the class of no homework skipped, 0, with a frequency of 2. The second point has the coordinates 1 and 5, meaning that there were 5 students skipping homework once. Because this is a line graph, the frequency points must be connected through line segments. Line graphs are simple and easy to read, which makes them a very effective way to communicate trends in the data to a large audience. We can only use this plot for relatively small datasets. Another type of graph, dot plots, are very similar in functionality to stem plots, but they are kind of simpler to read. A dot plot consists of dots or points where each dot represents a data point. These plots are useful to help find an overall pattern in the data. Consider the following data dealing with the hours of physical exercise per week. The dot plot for this data would be as follows. For each observational value, we represent the corresponding frequency as dots. For example, 0 has 1 point, 3 has 3 points, and so on. Importantly, we can extract meaningful information from this plot. For example, looking at the dot plot, we can identify the peaks, which are the bins that have the most dots. The peaks represent the most common values in the sample. In our case, 3 is the peak value. The most common exercise time is 3 hours per week. In many of the cases in statistics, histograms are used to display numerical data. One advantage of a histogram is that it can display large continuous datasets. It is applicable only to grouped numerical data, either discrete or continuous. A histogram consists of continuous adjoining boxes or bins. It has an horizontal axis and a vertical axis. The horizontal axis is labeled with what the data represents. The vertical axis is labeled either with frequency or with relative frequency. Importantly, the histogram can help you visualize the overall shape of the frequency distribution. In fact, a histogram is fundamentally a frequency table in 2D. To construct a histogram, you must first decide the size and number of bars, similar to what we did with the frequency table. Let's see this with an example. We have data about the heights in centimeters of 20 male semi-professional soccer players. The heights are continuous data since height is obtained by measurement. Looking at the data, we can see that the smallest data value is 145 and the largest value is 192.5. To calculate the width of each bar, bin, or class interval, the naming is the same, subtract the ending point, 192.5, from the starting point, 145, and divide the result by the number of bars. You must choose the number of bars you desire. Suppose you choose 8 bars. The boundaries are 145, 151, 157, and so on. Looking at an histogram, we can see different data patterns. For example, in our case, the height 180 is in the interval 175 to 181, and the heights 170 to 174 are in the interval 169 to 165. In continuous intervals, the standard is to consider the interval closed at the lower boundary and opened at the upper boundary. So, the interval 175 to 181 includes the boundary value of 175, but not the boundary value 181. Only the last interval includes the upper boundary. The histogram helps to give a quick notion of where is the center and how the data is dispersed, but unfortunately, and this is a major limitation of this plot, you do not have detailed information about individual informations as you would in, for example, a dot plot. Frequency polygons are analogous to line graphs, but they utilize binning techniques to make grouped data visually easy to interpret. If you remember, line graphs do not work with grouped data. So this chart is fundamentally a combination of a histogram and a line graph. To construct a frequency polygon, take the same steps as for a histogram. A frequency polygon was constructed from the frequency tables shown for the histogram example. We obtained it by first plotting the midpoints of each interval and then connecting them with line segments. A midpoint can be calculated from the formula upper minus lower, then divided by 2, and then you should add that value to the lower endpoint. The point labeled 148 represents the first interval from the table that contains 3 observations. The second point is 154, and it corresponds to a frequency of 2. Frequency polygons are sometimes more useful for comparing continuous distributions than histograms. This is achieved by overlaying the frequency polygons drawn for different datasets. The frequency tables, however, need to share the frequency bins. One dimension of the data that we want to sometimes consider in our visualizations is that of time. We may want to display the time aspect to show the chronological order of ungrouped data. A graph that displays the changing quantities or measurements as time progresses is called a time series graph. The following data shows the change in global surface temperature from 1951 to today. In the x-axis, we have the years over time, and on the y-axis, we have the change in temperature. Looking at the graph, we can see that Earth's average surface temperature in 2023 was the warmest on record since 1880. When recording values of the same variable over an extended period, sometimes it is very difficult to see any trend or pattern. However, once the data points are graphically displayed, some features jump out, as in this case. Let us see how we can create some of these charts in Excel. Excel offers a variety of options to help us visualize data. However, not all charts that we have talked about today are available. For example, the stem plot and the dot plot are not available. So instead, we have the line graph, the histogram, and the time series plot today. Today we have 3 datasets to help us create meaningful visual representations. In these examples, we will deal with Game of Thrones Imaginarium. Brief disclaimer: if you don't know what Game of Thrones is, it is a series that ran for 8 seasons between 2011 and 2019 and became one of the most popular shows of all time. The series had a profound effect on television and the fantasy genre because of its complex characters, its focus on political intrigue, and its dark, sometimes even bleak approach. So let us see Game of Thrones through the lenses of Excel charts. We are here at the Excel sheet where we have information about Game of Thrones. We have information about Season 1 and the 10 episodes of Season 1. The names of the episodes were, for example, Winter is Coming, The King's Road, Lord Snow, and so on. We have the dates, we have the average rating, and we have how many people voted to achieve this average rating. So it is clear what we can do with the line frequency chart. We can, for each episode, display the frequency of the voters. Go to Insert and select the line frequency chart that you want, which in this case is I want this one because it has some nice markers on. Okay, so what can I see here? That the most frequent episodes receiving votes in terms of votes is the 9th episode, and the least one is the 8th. So this is a lot of information about the battles. The battles were 38, from 1 to 38. They involved kings, different kings of different Westeros regions, and we have columns with information about who won, where was the battle, the type of battle, and so on. But what we are interested in this example in particular is the defender and the attacker side. So what I'm going to do is I'm going to create a histogram out of the defender size column. So I'm going to go to Insert again. Now I'm going to go to Statistics, and I'm going to select Histogram. And I can see here that most battles were between 100 defendant size and 1,300 defendant size. Okay, so there were some battles that had much more defenders, but generally they were in this interval. Going back to the first example, we have here the same information, of course, but we can extract here a different chart. Because this column is about time, we can make a time series plot with the ratings. So we can select both columns. We go to Insert, and then we select Line Chart. I'm going to select with markers again. And here we have the temporal evolution of the ratings. So you can see that the series, the show, was becoming more and more popular as the time went through. Okay, so now we can look at some examples in Python. Okay, so let's talk about Python examples. And the first thing that I'm gonna analyze is shoe collection. So how many shoes do you have at home? Some people might have 5, some people might have 7, 10, some people might even have 30. This is just artificial data, okay? But you get the idea. When I want to generate a graphic with this, I can call this library, which is called stem graphic, and I can generate a stem plot with it, okay? And here I say that the scale is 10. So if you look at here, you will know that the stem is 1, and here the stem is 2, as we have previously talked about. Okay, so I'm going to show this graph. I'm going to run it. Okay, so what do we have here? We have here the 0, 1, 2, 3, the stem, which makes sense because we have 0 here, 1, 2, 3, and so on. And we have the leaves here. So for the 5 comes from here, the 7 comes from here, and so on. So this is a nice way of showing the leaf plots using this library. Another example that I want to talk about is this one. It's about ages of soccer fans at a game. So one might have 27, another might have 16, and so on. And the stems. So from this data, I ordered the data and I calculated the stems. Okay, so in this case, it will be 1. Here it will be another 1. 2 comes from here. Another 2 comes from here. You get the point. Okay? And then we can use matplotlib to create the same stem plot. So it's exactly the same. The look, it's going to be a little bit different, but the idea is the same. It's a stem plot also. Okay? So this is turnaround, is vertical instead of horizontal, as we typically see it. But you can see here the stems here and the data here. You don't see the leaves per se, but you see the actual numbers. Imagine that I wanted to do a line chart with this data. This is the data of YouTube videos views. So we have 420, 380, and so on, 4 different videos, and we want to see the frequency. We want to see on average how much time how much views we have, or how much spread out the data of views is. So let's see this. Okay, so here we have the frequency line chart, and we can see that here is the number of videos, and here it's the frequency of each video. So some videos have less views, other videos have more views. In the 5th example, we care about the weight of firemen women, okay? It's very difficult to represent this in a dot plot immediately, so we have to make this function. If you don't fully understand the function, it's not a problem. You just need to use it as a black box to divide and conquer the problem. And the important code is this one, where we show the data, the weight in kilos of the fireman, of the firewoman in this case, and we call the dot plot. So let's see. So here we have the dot plot with the weight here and the individual observations here. We finally have an example that is about school and about the distance to school in kilometers for different children. Okay, so what we are going to do is we are going to generate data here in these 3 lines that have an average of 3 and a standard deviation of 2. And we're going to generate 1000 points. Why do I do this and not write the data myself? Because I want to generate a lot of data, because histograms and frequency polygons typically use a lot of data, and they make more sense when there is lots of data. So let's see. So we have here the histogram, and we have here the corresponding frequency polygon. So far so good. Thank you for watching and see you next video.